For solving for side A, which is adjacent to angle B, so we'll call that one side A, we'll use these two sides, the known side of 100 and this unknown side angle A, or sorry, side A, which is adjacent to angle B, and we'll compare the same two sides here in the known triangle of 2 and 1. So again, I'm going to write down make sure I write down the actual ratio, the actual side, which is adjacent angle B, okay, over hypotenuse. And I need to make sure that I'm clear which ratio, which direction the ratio is in, not just the sides I'm using, but the direction that it's in. So I'm going to compare this to side A to 100. Okay, and then this will be the known triangle. I could use this one here as well since we figured it out, but this one is much nicer number, so I'm going to use the side length of 1. Sorry, the hypotenuse was 2, and the side length that I'm comparing it to is 1. Okay, so again, I've made sure that I've got this, I've named the sides that I'm using. I've got it in the right direction. And at this point, I can just solve by algebra. And this one, I don't really need to solve by algebra. I can see that the numerator is half of the denominator, so I know that A is going to be a length of 50. Okay, so that ends up being 50. Okay, so then we can do the same things here. We'll first start off by using, we're going to use exact values in this problem. We're going to try to avoid the decimals here so we can get used to using exact values. If you want to confirm the exact values on your calculator, go right ahead and do that, but we're going to use these exact values here. Okay, so here we have 2 and 6. So using Pythagoras, I'm going to find the third side. Let's call this angle A here, and I'll call this side A. Okay, so I'm going to say that A squared, it is one of the shorter sides, it's not the hypotenuse, so I'm going to subtract. So 6 squared minus 2 squared. Okay, so I end up with 36 minus 2, which is 32. So then A works out to be plus minus square root 32. Okay, and then we'll just use a positive version of square root 32. Okay, so this side length then is, the A is square root 32. Okay. Now we just have to be careful with the square root. So again, if you don't know your radical algebra, okay, we can always convert those to decimals and use those decimal values. But again, I want you to start trying to use some exact values here. Now we can see by just inspection here that this triangle looks like to be exactly half the length. So that is double the length of that. Okay, and we can actually show this by showing that this is actually equal to, if I take the factor of 4 out, if I square root 4, I get 2, and I'm left with square root 8. So it's double the length of square root 8. And I can see that from here to here, there's a scale factor of times 2. So this triangle is double. And again, we can show that this is going to be double this. Sorry, this length here is double the square root 32 by factoring out. In this case, I'm going to factor out a 16. Okay, so 16 times 8 is 128. And so I'm going to factor out the 16 and square root it. I get 4 square root 8. And so this is going to be double the length of that. Okay, so this is just a little bit of radical algebra. I don't expect you to know that right now since we haven't gone through that unit. However, we could always convert these to decimals and see the decimal values are exactly double here and exactly half here. Okay, so we kind of know the answer, should know the answers just by using the scale factor between triangles, but we're going to now use trig. So I want to solve for this side here. I'm going to call this side x. Okay, so I'm going to use relative to angle A, so make sure I know that where angle A is. So relative to angle A, it is adjacent side, and in this case I'm going to use maybe the hypotenuse because it's a nicer number. Okay, so I'm going to go adjacent A, give myself a little bit more room to work, adjacent A compared to hypotenuse. Okay, so I'm just going to write that. And we're just going to try to shorten things up a bit here. Okay, we want to try to be a little bit more efficient with what we're writing down. So adjacent angle A is x, hypotenuse is 3. I need to do an equivalent comparison of two sides within the same triangle. So adjacent to hypotenuse is 2 to 6. Okay, solving for x, we can see that it is a scale factor of 2. So we can solve for x. We get, I'm going to do this algebraically. And we get x equals 1, and that's what we kind of would expect based on the scale factor. Okay, so then we're going to do the same thing over here. And maybe I'll use the awkward side. Okay, so, and we're going to solve for, we'll call this side y, which is a hypotenuse. And so I'll use, well, it's probably better to use these two sides, okay? But we could still use this awkward number here and this awkward number here. And we can see that when we do a ratio, our ratios are going to be half anyways. But let's avoid the radical algebra. We'll just stick with the easier side. So here I'm going to again use adjacent A. So there's my angle A, so I'm going to use adjacent A compared to the hypotenuse. So I'm going to name that side. I'm going to compare those two sides in the triangle that I'm trying to solve for. And I'm going to use those same two sides in this triangle that I already knew. So 2 to 6. I could also use 3 to 1. They're all the same ratio. And we can see that by inspection, again, y should be 12. If we want to solve this algebraically as well, we can solve it algebraically. We cross multiply. And so we end up with y is equal to 24 divided by 2, which is a 12 that we expected. Okay, so y is equal to 12. Okay, so again, feel free to solve using the scale factor, but the point of what we're doing today is we're trying to start to use these ratios within the triangle. So comparing the same sides of the same triangle, different sides of the same triangle. And these are actually these are trig ratios. This is what trig is about, is comparing sides of the same triangle. Okay, and we're not using the scale factor. Although the same proportion exists this way, we're going to do the proportion comparing sides like this. Okay, and that's the difference between scale factor triangles and using trig.